How's it going, guys? So today we're going to talk about synthetic division. Now, synthetic division is just kind of a shortcut in which we're going to use dividing polynomials, and it has a couple of special cases and then there's a couple extra things we can do with it that help us out quite a bit, and it can give us some shortcuts sometimes. Now, first off, we have to know when we can use it. So synthetic division, firstly, can only been used when we have some sort of binomial combination with a linear term and a constant term. So, in other words, what that means in, say, plain English is when we have x plus something or x minus something that we're dividing by. And we're going to call that something k. So if I'm trying to divide by something, say like an x squared or an x cubed, into something else, I can't use synthetic division here. The shortcut doesn't work then. We're going to have to use long division, and it gets a little more complicated, a little more annoying, but it's still possible to solve. Now, most of the time, these problems are a lot easier if you just see an example or two. So here's what we're going to do. I'm going to write a problem on the board. So it's going to be negative x cubed plus 4x squared plus 9 divided by x minus 3. Okay. So first off, we have to figure out what our k value is. Now, this is x minus k. So I have to figure out what I need to plug in here so it turns into x minus 3. Now, most people, they look at it here and say, it's x minus 3, x minus k. Okay, this is going to be a negative 3. Well, that just doesn't work. The way you can think about this is just take the opposite number we'll say we're in here. So this is a negative 3 in here. That's what it seems like, but actually it's a positive 3. So you always just take the opposite of whatever you see. If you see a plus 3 in here, you're going to use negative 3. So what we're going to do is write that positive 3, our k value, right outside here. So we're going to have this long box, and it's going to look kind of weird. We're going to write our coefficients inside this box. So I look at here, and I say, okay, I have to look at all my coefficients, every single coefficient I have. Most people, what they're going to write down is this when they first see this problem. This is wrong. Do not do it this way. They're going to write a negative 1 for here, a 4 for here, and a 9 for here. Now, that would be right if we took into account every single place. Now, we have a cubic term, something cubed. We have a quadratic term, something squared. And we have a constant term with no variable. We are missing something between these two, which is called our linear term. We're missing our x value. So, because we're missing that, we have to write 0 there, and then the 9. Every time we're missing something like that, we have to have that placeholder there. We have to count this in and just place it in there just for our computational purposes. So the steps are extremely easy after we get to this point. First, you always bring down the first number. So our first number here is a negative 1. Just bring that bad boy straight down. That's it. Okay, next. We have to multiply k by that number. So what I have to do is multiply 3 by negative 1. And what I'm going to do is I'm going to place that underneath this 4. So that gives me a negative 3. Okay. The third step, and we're going to do is repeat this, is add down, and then repeat 2 and 3. So we're going to keep multiplying k by the bottom number, placing it up, and then adding down every single time. So I add straight down, I get a 1. Okay. 3 times 1 gives me 3, nice and easy. 0 plus 3 is 3. Then I have to multiply these two together. 3 times 3 is 9. And then I add straight down, I get 18. Now, this just gives us numbers. What these numbers are coefficients of our answer. And this right here, I always circle it, just a habit. This is my remainder. So if these are coefficients, we always start off with our constant, then we go to our linear, then quadratic, then cubic, then quartic. We keep going in that order. So we keep going the lowest till we get higher and higher and higher. So this is my constant, linear, quadratic term. So these are just the coefficients on these terms. So my actual answer is going to be a negative x squared plus x plus 3 plus 18 over, you always put your remainder over your divisor, x minus 3. Boom. Now, that's it for this problem. It looks a little complicated at first. You look at this and you're like, okay, well, I don't know what the heck these numbers are. I don't know what I'm supposed to do when I convert it. That's where most people get held up. And then take into account when you're missing something in the middle there, you have to think about that. You have to pay attention. You have to try these problems in which you're going to have to replace or plug in that 0 value for, let's say, your cubics, quartics, quadratics, anything linears. And I'll give you another example where you're going to have to do that. Okay. If you feel like you understand this somewhat, what I'm going to want you to do is try this problem on your own, and then, pause the tape, pause the video. Try this problem on your own, and after you've tried it, unpause it and see whether you get the right answers, whether you follow the right steps. Okay. Now the problem I want you to try is 2x cubed minus x minus 7 divided by x plus 3. Now, pause the video if you can. Try this problem on your own. I'll wait a second or two for you to pause it. Okay, if you paused it, welcome back. If not, I don't know what you just did, but you didn't do what you're supposed to do. But anyways, we're going to start this. My k value here, it's x minus k. Remember, I said take the opposite of this value. You see a positive 3 there, your k has to be a negative 3. So I'm going to plug in a negative 3 right there in that spot. Okay? Now, I got to look at all these coefficients once again and put all the coefficients in order here. Now, you're missing something here. You're missing a quadratic term. You're missing your x squared value. So what I have to do is say, all right, this is my 2 for my x cubed. X squared is a 0. X is a negative 1. And negative 7 is a negative 7. Bring down the first number, 2. Multiply these two together, I get negative 6. Put that here. Add straight down, negative 6. Multiply these together, I get an 18. Add straight down, 17. Multiply these together, I get a negative 51. And then I get a negative 58. Okay. Nice, simple, nice, easy. The hard part here is not writing it out like this. The hard part here is converting it. That's what most people struggle with. This is going to be my remainder, constant, my linear, and my quadratic. All I got to do is just put those coefficients in front of those variables and put this over my divisor. So I have 2x squared. I got negative 6x. I got 17. And then I have a negative 58. Okay, so I can do minus 58 over x plus 3. Or the same answer would be plus a negative 58. Either one I'm okay with. I would probably be more okay with than minus 58, but when we talk about different things, you're going to get a little more confused. So this would be my answer in this case. And that's synthetic division. Synthetic division is not difficult, it's not hard, it's not lengthy. And it's really quick once you actually get the hang of it and just say, okay, I have 2 times 3. Okay, that's 6. I just add 6. So it's multiplying small numbers and just adding simple math. Now, synthetic division can also be used to evaluate functions. And what I mean by that, if you don't care about the whole process here, that's fine. I'm going to write down why this works. If you don't care about that, you can skip ahead of like maybe 30 seconds, maybe a minute or so until I'm done with this proof. Now, so we'll see what happens. So if I have some f of x, some function that I'm dividing by an x minus k, which is what we've been doing for synthetic, x minus k. And I set that equal to, it's going to give me my quotient plus my remainder over my x minus k. So this was my answer plus my remainder. Okay, that's fine. So what I'm going to do now is multiply everything here by x minus k so I can clear these fractions. So what happens here is these cancel off. These cancel off, and I'm just left with qx times x minus k plus r. So this function is qx times x minus k plus some remainder. Now, whatever value we plug in here, the k value we plug in here, we'll see what happens there. So if I have f of k now, not just some random variable x, I get q of k times k minus k plus r. K minus k is just 0, which is going to cross off that entire thing there. So f of k is just r. Now, this looks really confusing. You're probably wondering, like, why am I doing this? But what that tells us is if we use synthetic division for any value here, it's going to be the same thing as plugging in that k value into my function, and my remainder is my answer. So what that means is we're going to use synthetic to evaluate functions, and our remainder is just the same thing. Just pay attention, you'll understand. Now, the problem I'm going to give you looks like this. Evaluate 5x to the 4th plus 2x cubed minus 20x plus 6 for x is equal to 2. Okay, now we can plug this in by hand. I'm going to plug it in by hand first and say, okay, I have 5 times 2 squared plus 2 to the 4th plus 2 times x cubed minus 20 times 2, this should be 2, plus 6. Okay, then I have to say 2 to the 4th. This is going to be 5 times 16 plus 2 times 8 minus 40 plus 6. Okay, this is 80 plus 16 minus 40 plus 6. This is 96 minus 40 is 56 plus 6 is 62. Okay. So if I use synthetic division now, with a 2 right here outside, and all my coefficients, I have a 5, I have a 2, I have a 0 for my x squared, a negative 20, and a 6. My remainder down here should be 62. That's all. I bring down my first number. Gives me 5. 5 times 2 is 10. This is 12. This is 24. This is 24. We have 48. We have 24. 24 times 2. Wait a tick. 10, 12. Oh, this is 28. Oops. This is 56. 56 plus 6 is 62. We got the exact same value out. both times, but one could be easier than the other. If you're not comfortable with putting anything to the fourth power, cubing something, putting something to the fifth power, I would use synthetic division, especially for the really long ones, like x to the eighth, like something like that. It's gonna be a lot easier to use synthetic and just deal with simple adding and subtracting than dealing with raising things to exponents. Now, it's up to you, but this is one small application that you can use with synthetic division. If you guys have any questions, you guys know how to contact me. Have a good one.